Okay, this is either going to be a big failure or it's going to be awesome. And let's just hope it's going to be awesome. So if you're subscribed to any of the same group of people that or is it called subscribed? No, if you're following the same kind of people that I'm following on Instagram, you probably already came across these amazing videos where people print with clay. Needless to say, I got pretty inspired by that. I think that these thick layers of extruded clay just look so awesome that I just have to try it out for myself. I came up with a design that I think is going to work, and this is the main bracket for this. And it's going to work like this, that you have a normal syringe. This syringe is already pretty dilapidated because I used it for... what's it called? Oh yeah, I used to degas my brake system with this syringe. That's why all these markings are gone. I wanted to start off with a fresh one, so I bought a couple more of them. I first got this syringe, thinking that it would be exactly the same as this one. And in the pictures they were the same, but what I got is something different. It's probably going to work as well. I could maybe print an adapter for this, but this would be just much simpler because I think it's a proper size, and yeah, I thought this would be just much simpler, so I just ordered a couple more, 2 more to be precise, and I thought that these were the same as this one. Something that went wrong, and I bought exactly the same ones again. But it doesn't matter, I'll make it work. I think I'll just use this one. So how this is going to work is that this syringe is going to be mounted in here, and then with a press fit you can turn it in place like this. And right now this is still pretty flimsy, but that's because I'll mount a bracket to these 6 holes. This bracket to be precise. And this is the bracket that I'll use to mount the entire assembly to the 3D printer. I totally forgot that I ordered the threaded rod a bit too long because I couldn't get it any shorter, and now I have to shorten it. But first I have to screw this out again. Easy! Now, why didn't I film anything of this? Well, I only have hand tools and I didn't want to share the struggle with you. So I did it for you, because I care about you. There we go. Let me see if I can find a motor somewhere. Here, I'll take you with me. Oh, nice. It even still has the same setup that I used for my previous video, which is perfect. I'll need that right now. You come with me. Perfect. Now let me quickly get some power for the Arduino. Okay, so I have 2 options now. Either you believe me that it's turning, or I set up the time lapse. So I set up the time lapse. I have some clay here. I have no idea whether this is the right clay to use. It says terracotta. To be honest, I have absolutely no idea about clay, so I just have to try this out. So let's say here, soft natural clay. It sounds about right. The only thing I can tell already is that it's probably way too thick, so I'll have to thin it down with some water. Let me take a knife. Okay, I'll open this stuff. The last time I played with clay was probably in kindergarten. The consistency is nice though. Feels really nice. Yeah, it's nice, but I can already tell this is way too thick. So, I already took some water and a cutting board. And I think I'll have to wet this down somehow. Let's start by dipping it. Here's a little fun fact for you. I used to study environmental sciences, and part of the degree was to take courses in geology. What I've learned there is that if you want to find out whether clay is really clay, you can put some in your mouth and chew on it, and when you feel the particles in your mouth, or when you hear the particles in your mouth, then it's sand and not clay. And if you don't hear anything, when it's just totally smooth, then it's clay. So let's try this out. It's actually not clay. There's definitely sand in there. In German we say, Sand reinigt den Magen. Boah, the taste is... I think the consistency is... it's pretty good right now. Oh. Most of you probably already know what this is, but to the ones who don't know what it is, it's the stepper motor that's losing... whoops. It's a stepper motor that's losing steps. So that means that this is still too viscous. It's the next day because yesterday I mixed it all with water and then it started to get kind of crumbly. So parts of the clay were really wet and other parts were kind of crumbly, and I couldn't really mix it in really well. So I decided to just let it sit for a day, basically. And it looks much better now. It's very homogeneous. I'm not sure about the consistency though. It's still, I mean, yeah, it is kind of soft, but is it soft enough? I don't know. Okay, perfect. Let's mount it to the printer and start the print. Now for the big question. How am I going to screw these two screws in? Oh, don't worry, I solved it without your help, but thanks anyway. Very nice. Now that we know that it's working, let's do some maths. I've made some calculations to see what the extrusion multiplier is going to be like, and I've came up with these calculations. So with the current setup, so this is the current setup. It's a very normal Mark IIs filament pushing setup where you have a little hop gear that's driven directly by the motor, and this one has a radius of 10 millimeters. Then you have the filament that gets pushed through. This has a diameter of 1.75 millimeters, and with this information I can calculate how much volume is pushed through the nozzle per revolution of the motor. Now let's look at the clay setup. So I'm using a threaded rod with a single flute and a 2 mm pitch, which means that this gets pushed down by 2 mm for every revolution. I've also measured that 90 mm of the syringe correspond to 60 milliliters in volume, and then we can calculate that down to 2 mm and we come to a volume of 1300 cubic millimeters per revolution. With these two values we can now calculate the extrusion multiplier by just dividing the first value over here by the second value over here, and we get the percentage that we have to set the extrusion multiplier by. In Cura this is called the flow rate. So what do I have to change in the slicer? At first I have to turn the Z-homing off, because the Z-homing offset of course is now totally off. It's easiest to just turn it off and Z-home manually. Then I have to set the extrusion multiplier to 11.3%. Of course only if I didn't do any wrong calculations here, but we'll see later on. Then I have to set the nozzle diameter to 3.5 millimeters. Of course that could also be wrong because I measured it by hand, so I might be a bit off on that. And then I have to adjust the layer thickness and speed, of course. Oh, look at this layer view. This looks so good.
Why is my fan on, by the way?
This looks really nice, I'm pretty happy with it. Now, on the bottom you see that it's very thick, so apparently I either measured something wrong or I calculated something wrong, or both. But anyway, at the third layer I just dialed the flow rate back to around, I think, to 50% of its flow rate here, and that basically seems to be the perfect flow rate. Another thing I'm realizing is that the carbon fiber rods cannot handle the stress. I think they are bending slightly, and that causes this frame to jitter. I'm not sure whether you can see it on camera, but yeah, it's really jittery because, well, it's binding up all the time. I mean, it's not so bad because this clay is so viscous that you won't see it in the print. But it's definitely something to note, especially because I'm already considering for a longer time to replace those carbon fiber rods with proper rods, because, well, to be honest, I think they're a bit of a gimmick. Oh, okay, I got a bit worried there because I treat maths basically like a religion, whereas they are basically never wrong. And so I had a closer look at my maths here and I realized that I took the radius of 10 millimeters, but it's actually not the radius that is 10 millimeters, but it's the diameter that is 10 millimeters. So the radius is 5 millimeters. And that makes the maths here pretty easy. This is around 30 or 31, this is also 31, and if you calculate this is halved as well, so it's 57.56, and then we can go down here. So we take these, this is wrong, this is our 57.56. I'm writing really badly here because the camera is in the way, but if you do this, we come to the value that is half of that, which is 0.0565, or 5.65%. And that solves basically everything. This is perfect.
I just stopped it because I saw it falling over on this side and I wanted to save the print, you know.
Now let's try printing something a bit more narcissistic. I have this piece of paper here, which I think will help me later on to release the print easier because I can just let it dry on the piece of paper. Now, of course, it's not perfect because, well, the layer lines are kind of big. I mean, I kind of like it, but on the other hand, you do lose quite some detail with the big nozzle like that. Another inherent problem, of course, is that the clay has to be soft in order for it to be extruded. But on the other hand, when it gets too soft, it cannot support itself anymore once you start to build up more and more layers. So in order to solve that problem, you basically have to be able to print with clay that's less viscous than the clay that I'm printing with. And the way I've seen other people solve that problem is by using a combination of two different kinds of extrusion methods. So first they pressurize the clay with compressed air, and then they use an auger to feed the clay into the nozzle. Now, for those of you who don't know what an auger is, it's basically a long screw that screws whatever it is it's screwing from one place to another place. You can use it, for example, for water, for grain, basically for everything that behaves like a fluid. So basically, I think there's a good reason why no one is using the setup that I built right now. And that is that I'm just super smart. No, the syringe is just not made for pressures like that. You cannot endlessly put pressure into the syringe. They will deform and deform and deform, and I don't think you can push it much further than I'm doing right now. Now that I'm already complaining, I might as well point out another problem that I have with this current setup. The amount of clay that fits in this syringe is just not really enough. You can print, of course, tiny things, but here in this print I had to stop the print midway because I just ran out of clay. This is basically all you see here is infill material. That's not supposed to be the outer layer. It is fun, don't get me wrong. It's awesome. I would have never thought that I could print clay with this pretty printer. Oh, by the way, if you want to know what this printer is, I built it myself, and I have a playlist which I recommend you not to watch, and I have it linked up here. As always, you can download all the files you need for this project directly from my Thingiverse page, which I've linked in the description below. And I haven't made it yet, but it will appear somewhere around here. So definitely make sure that you check it out. As always, I think you know it by now, I'm running out of time again. And I already have an entire new segment filmed that I wanted to include into this video, but I think it's better to just wait a little bit and release it as a part 2. So make sure you subscribe so you won't miss that video. And other than that, thank you for sticking with me for these entire something like 20 minutes or so. That's quite a bit. And I hope to see you in my next video. Goodbye.